Thanks for joining the Planning for Multi-Cloud presentation. I've done quite a bit of research and conversations with the community, thinking through what is multi-cloud, what are some of the challenges faced. This presentation is geared towards the enterprise architect that has to look at a holistic view of multi-cloud. I'll define multi-cloud in a couple of minutes, but overall the audience for this presentation is the enterprise architect, not necessarily the application developer, but the enterprise architect that has to worry about compliance, security, performance, networking across a dozen or so apps that you're looking to deploy or leverage in the cloud. We won't spend a whole lot of time on this next slide other than to put it up for those on replay. If you've connected with this webinar, chances are you know who I am and you know how to find me. So there's the obligatory slide. We're going to try and cover an awful lot in the next 40 minutes or so. We'll cram as much information in as possible. What I wanted to do was not only give some practical theoretic overviews over what you should do in planning for multi-cloud, but point you in the directions of at least some vendors to have conversations. This podcast or this webinar is not sponsored by any particular vendor. I have put stars next to vendors' names that I have done business with, for whether it's advisory work or creating content, but this is not a sponsored webinar. So let's go over the agenda. This is what you found in the invite. We'll go over a picture of the typical multi-cloud environment. I say in this presentation that it starts with networking, but actually your multi-cloud journey starts with data. Unfortunately, there's not an awful lot of solutions and products on the market to really help you with the holistic challenge of data in the enterprise. We'll get into that a little bit when we talk about data protection and considerations around data. And then we'll have kind of a freelance conversation at the end about workload and change management. Specifically, we're going to talk about kind of the promise of Kubernetes and the reality of where we're at as a industry. So I found this picture to be more controversial than it should have been. I took it as a foregone conclusion that everyone considered software as a service a proper cloud technology that you should consider when you're thinking about multi-cloud. And as recently as this morning, I was in a back and forth with peers on LinkedIn that kind of take the financial analyst view of software as a service. So specifically, I put on this slide Office 365. When Microsoft reports their earnings, typically a lot of the pushback you get from industry analysts is that Office 365 shouldn't be included in the mix of cloud revenue because, you know, it's Office productivity software. How magically, just because it's Office productivity software is not SaaS, which it is SaaS, the argument can go, you know what, if I'm consuming SAP HANA S4 as a SaaS offering, and it's driving 70% of all of the world's revenue, SAP in general, or transactions, then somehow that's not SaaS. The reality on the ground is that when we adopt solutions like like Workday or in Salesforce.com, Office 365, Oracle Business Suite as a SaaS offering, these are critical parts of our business, critical workflows of data goes through these services. So I put them on equal par as a AWS, Azure, or Google Compute when we're considering all the things we need to do to protect data, to ensure compliance, to ensure end users have access to the applications and services that they need, these solutions become a critical part of our infrastructure. One of the use cases that I gave as I made the argument that SaaS offerings in Office 365 specifically is a part of the infrastructure of multi-cloud. Think through the scenario I'm about to give. You're a developer working on a CRM marketing campaign. In AWS, you're hosting a bunch of objects that are basically sales material, marketing material, collateral that you're hosting as part of this campaign. You have a customer portal. The customer can come into the portal, use their credentials to download this material. If you're using also Salesforce.com, then as a developer, I can easily create a scenario or even a function in AWS Lambda that when I get a trigger from Lambda that says Keith Townsend has downloaded the latest marketing material on project XYZ, I trigger a Lambda function that will then go to Salesforce.com to update the customer record for Keith Townsend, who works at the CTO Advisor, that says the CTO Advisor is interested in project XYZ, follow up with the user. That is multi-cloud. At no point in that workflow did the technology or logic touch the private infrastructure. We can go with all kind of variations of that movement, but this type of activity is happening in the enterprise, whether as infrastructure professionals, as IT professionals, we realize it or not. People think of these things. I'm not a developer. I'm not even that great of a business analyst. And I came up with this simple workflow that people, when you remove the barriers of IT and you're exposed directly to these services, start to build. So the ideal that Office 365, Salesforce.com, Workday, or any of the other SaaS offerings aren't part of your multi-cloud strategy is a fallacy. You have to consider this. This is where I went back to the first conversation, that the first step in understanding your cloud journey is to get to the data, understanding data flows, workflows, what data exists in what platforms, and what are the potential use cases for the data in these platforms. So starting with the network, I found it pretty difficult to draw a picture of how a typical network for a multi-cloud infrastructure will look. If we go back to the previous cloud, I think in our minds, this is where we would, kind of have a firewall at the perimeter of the data center, and services will kind of all come into that single point, and then users can access those services out via that traditional perimeter path. In reality, that's not what's happening. This is, again, to pick on SaaS services again, users are going to these SaaS services directly. I think the industry tried for a little while to hide Office 365 behind VPNs, and some companies still do it. But for the most part, customers are coming in, or end users are coming into solutions like Office 365, Salesforce, Workday, et cetera, through the public internet. If they're not doing that today, they probably will do it in the future. And then we have this scenario of the use case that I just gave, where you create some type of Lambda function that transacts on a Google compute platform leveraging machine learning, or on a blog stored in SharePoint on Office 365, that traffic does not go through the private data center, or it shouldn't have to go through the private data center. You could force that traffic through, but you need to give some thought to that question. What is your networking policy? And this is separate from security. Your networking policy around multi-cloud. When you want to enable end users, developers and such, to access resources from AWS into Google Compute or Office 365 or Microsoft Azure, what path do you want them to take? As you get into the security conversation, it starts to go around, well, how do I enable security in a manner that protects information? I posted a unpopular opinion on Twitter the day before yesterday, which is that firewalls no longer protect the perimeter. I got a lot of pushback. I expected to get a lot of pushback from that statement, because people still think of the perimeter as the data center extended into the cloud. What do I mean by that? Well, we put traditional firewalls inside of AWS, whether those traditional firewalls are individual instances with a firewall code installed on it so that we're filtering all of our traffic through a gateway in AWS out, or if we're running microcode on each AWS EC2 instance that has distributed firewalls inside. That is a very data center specific construct of a perimeter. That perimeter no longer exists. Go back to our example about AWS, Lambda running code on Office 365. There is no firewall that protects against that traffic flow. Matter of fact, I'm not 100% sure. We've gone back and forth with this with AWS, with in some accounts that I've had, and on Twitter and LinkedIn, about a potential design that will force traffic through a VPC for Lambda code that goes into the data center. The traffic is analyzed at a firewall, then goes back out to Office 365 and takes the same path back into your data center. That is convoluted. So this is something that you have to give a great deal of thought to, from a security perspective and also from a performance perspective. If we start to tunnel all traffic through a choke point in the data center, are we really leveraging the public cloud for what it's worth? So let's talk about a couple of different scenarios of how we design a multi-cloud network. We can go with that latter example that I use, which is internet only. You know what? Let's use the public cloud as it was meant to be used. End users sitting in their home office will access resources on public cloud through the naked internet. Obviously, all services will go through that Comcast or AT&T local home connection. This reduces the overall friction from consuming cloud services. However, you have less control and visibility. From a compliance perspective, if you're in a highly regulated industry and you have PCI data, I think Office 365 for a while wasn't even certified for PCI compliance. You open up quite a bit of pain when it comes to keeping your infrastructure in compliance. Enter the first obvious, I think, solution, which is VPN. We see this a lot. I can establish a VPN connection to all of my multi-cloud service providers, AWS, Azure, Google Compute, and then force all traffic for Office 365 to only be accepted from a VPN connection from my data center into the SaaS offering, which forces end users to have to VPN into your data center and take that path. Obviously, you solve the security problem, but you increase overhead. I can't stress this enough, especially as you get larger and you have more and more sites, more and more entry points into your environment. If you are a global company and you have a data center or a point of preference in Europe, US, Asia, and you want to use the cloud service provider closest to the end user, forcing this VPN type access creates an abundance of complexity in your environment. You have to decide how you're going to load balance that traffic so that end users are going to the resource closest to their environment. Are you going to use DNS? Or are you going to use some type of geographic-based load balancer that goes upon point of entry into your network to determine where this traffic goes? How are you going to share routes with your public cloud provider to ensure that traffic always goes over those VPN tunnels? How are you going to handle failover? The complexity goes on and on when you go through a VPN option. Then let's talk about the obvious disadvantage, which I alluded to other than overhead, is performance. When you have a finite amount of bandwidth leaving your data center, especially internet bandwidth. One of the complaints about internet bandwidth is that it is unreliable from a performance perspective. Having the distributed model of internet only, allowing users to go in through their private connection, the choke point now becomes the internet port at the home user's location, and the SaaS service provider's ability to accommodate that traffic. And that's usually, not a problem. So the next level of options is to get some type of dedicated connection, an express VPN, an express link or direct connect, some type of dedicated connection to your SaaS provider. This obviously is going to offer more security than both VPN and internet only. It can offer less complexity than VPN, but you have some of the same challenges from a performance perspective. You create the same bottleneck conditions, but generally, cloud providers allow more bandwidth with these dedicated connections. You can get 10 gigabit connections, direct connects, versus a VPN, last time I checked, from AWS to your data center was limited to 4 gigabits per second. So you can increase bandwidth, hence increasing performance and relieving a bottleneck within your environment, but you reduce the overall flexibility of your options. One other point when it comes to dedicated connections, and we'll get to it when we talk about kind of the interesting vendors in this space, SaaS services are most of the time either co-located or close to public cloud instances. So you'll have a lot of public cloud SaaS services that are based in Amazon's AWS. One of the advantages of a dedicated connection to AWS is that you can then funnel all of the traffic destined towards a public cloud, a SaaS hosted on a public cloud provider such as AWS. You can funnel that through your direct connect. So, it kind of kills two birds with one stone. There's complexities in that we'll get into in a future webinar, but it is a compelling solution to be able to have all of your SaaS traffic and all of your infrastructure as a service traffic over a single dedicated connection. So who are some of the interesting network vendors in this space? I broke this down into 3 different areas: SD-WAN, circuits, and hotelers. SD-WAN, I think when we think of SD-WAN, we typically think of reducing MPLS costs and ensuring that you can get the same level of performance over the internet as you can over a dedicated circuit, if not better performance, the ability to intelligently pick routes. Well, it's that ability to intelligently pick routes that makes SD-WAN even more interesting for multi-cloud. There are plenty of options there's no shortage of vendors that will help you put virtual appliances inside of your VPC or your virtual networks in Azure, Google Compute, AWS, to intelligently route traffic over the best path. It's no different than what we do in the data center. So Riverbed, Viptela, which is now owned by Cisco, VeloCloud, are all interesting examples of SD-WAN solutions that extend beyond just the private data center and private network. Circuits, you know what, this is, old school. I need a connection from my data center into the public cloud. Baby Bells and resellers such as CDW are doing really interesting things when it comes to circuits. One of the cool things is that they are becoming a one-stop shop. AT&T, for example, bought a SD-WAN company, so now they can offer some of the same SD-WAN capability that users are using to avoid MPLS, to intelligently direct traffic in the hybrid and multi-cloud use cases. You can go to CDW and as well to get these solutions. Hotelers, Equinix, QTS, Rackspace, all offer either direct connects to providers, or they'll terminate a circuit within their infrastructure and give you a portion of a circuit. So let's say a port to AWS is typically 10 gigabits. A hoteler will say, hey, you know what, we'll give you a 1 gigabit connection or a half a megabit connection, or the whole 10 gigabits to cloud providers. So not just a single cloud provider, but they will share routes to you to all of the cloud providers they have co-located in their facilities, so that you kind of, again, kill one bird with one stone. You can get you don't have to go out and get separate connections to Azure, AWS, Google Compute, Workday, Salesforce, etc. If you get a single connection into one of these hotelers, they'll put you as close as possible, latency-wise, to these services. So, give them a call, have the conversation. So let's talk about another big topic, which is data protection. I've kind of lumped security and data protection all into one slide, because again, each one of these areas is a webinar in itself, and I want to directionally give you a place to start your research and go. The number one challenge, in my opinion, of multi-cloud when it comes to security around your data is the differentiation or differences in taxonomies, control planes, and capabilities. There's a ton of other considerations that we're not going to go through in this webinar, but from a high level, I wanted to help you understand why security in multi-cloud is so much difficult than security, even hybrid cloud, where I have my private data center in a single cloud provider. In a private data center in a single cloud provider, what is a web server today behind a elastic IP address should be a web server tomorrow. I can create that policy. Where it starts to get complex is that what's a web server today in AWS may not exist tomorrow. So I have to move up in my abstraction layers and help to understand groups of services and setting up my firewall in that hybrid model between those two edges of the network. I have my private data center, I have my single cloud provider. Then as I start to go deeper, I realize that the firewall concepts break completely. Lambda or TensorFlow or dedicated path services, EKS, things that start, or, very simply, object storage. These things start to break down concepts of endpoints within the enterprise. What is an endpoint when it relates to Lambda? Modern day firewalls don't have that context to know that, if I can say I allow port 443, which is the Lambda code, to run against a web server, but I don't know what that Lambda code spawns or has done. I can't properly set up zero trust. Now you expand that beyond. What's serverless constructs in AWS is not the same as serverless constructs in Azure or Google Compute. Lambda objects in AWS does not equal Azure functions in Azure. How do I control traffic between those two quote unquote endpoints? This is what I mean by control planes. In order to put policy around Lambda, I need to go into IAM in AWS, configure those controls. Those controls don't necessarily translate in a capability perspective in Azure. I may be able to control some aspects of serverless functions in AWS that I cannot control in in Azure. Then extend that out to that original use case that I gave of using Lambda code to execute into Salesforce.com. Now we start to see the complexity of taxonomy and capability. The two just don't translate. This is something that I wish I could point you to a vendor and say they've solved this problem. They haven't. You have to do you have to roll up your sleeves, do the hard work, and help and think through how you're going to deploy security policies across the separate security concepts or domains. So a couple of topics that's a little bit easier to get our minds around, which are backup and disaster recovery as it pertains to data protection. Some of the things that you should consider when you think through the simple concept of backup is, one, I'm surprised I still have to say this, but I have to say this, you have to back up public cloud. You have to back up SaaS services. You have to back up infrastructure as a services as a general rule of thumb. Especially the case when it comes to infrastructure as a service, AWS, Azure, Google Compute, Oracle Cloud, etc. will not back up your Windows instances or your Lambda code or anything you deploy in AWS. It's on the end user to back up these infrastructure as a service based components. The infrastructure itself is guaranteed against failure, but not the workloads running on top. If that data is somehow corrupted, you need to go back and restore it from whether you're using built-in replication in AWS, et cetera, you need to have a plan for how you back up your data. Software as a service, generally speaking, is not backed up. That's a general concept. Things like Workday, those services are going to be backed up. Office 365, a little bit less clear whether or not Microsoft will be able to say, I'll give you a backup of a Visio that you had 2 months ago. That is probably not going to happen. A question from the audience is, can I talk about past backup for a little bit? And I think I can equate past backup to the same as I think what I just said about Lambda. So I can deploy Lambda code. And when I deploy Lambda code, that underlying code is stored in a S3 object. And then it's deployed on demand. If I make code revisions, if I make revisions to that underlying code, it's upon me to have some type of methodology for backing up. So if I want to revert back to a version of my Lambda code that I had 6 months ago, chances are I won't be able to go back to AWS and just hit rewind. The same thing with PaaS services. So if I'm consuming a database as a PaaS, this gets, kind of in between infrastructure as a service and this gets in between infrastructure as a service and software as a service. You need to check with your PaaS provider, especially in the case of a database. You may be consuming a database as a PaaS, and part of that consumption is that they have some type of retention policy. They may not have a retention policy, and they may just provide the underlying database platform as something that you consume and build projects on. We'll get into how do you back up these platforms in the cool vendor section. But for the most part, you have to worry about state in all of your software as a service, infrastructure as a service, and especially PaaS platforms. How do I back up the configuration? Because the configuration in a lot of these instances is the important part. I laughed at someone's pain earlier this week. The Packet Pushers on their Network Break podcast talked about a minister that had passed away, and the new minister was kind of slamming the dead and saying, you know what, the guy just wasn't good. He configured these core switches and he died without giving the password. We have no idea of the VLAN configuration, et cetera, et cetera. It's just a black box. We don't know what to do with this server. Well, that's the state. The service itself can be as resilient as you want it to be, but if you need to revert states, you need to pay attention to how you back that up and restore it. Disaster recovery. This is, again, something that's on paper seems simple. Disaster recovery can be as simple as a AWS, I want to protect between a service and a AWS region going down, or AWS region going down, or as complicated as I want to fail over from AWS to Azure, or from my private data center into one of the public clouds. This is a big topic. You need to decide if you're going to take an application by application approach to it. So I'm going to build cloud native applications that understand that the underlying infrastructure is based off of Azure in my private data center, and I'll build disaster recovery into that, and disaster recovery awareness into the application. Or if I'm going to build the disaster recovery awareness into my infrastructure. This is what we do in the infrastructure today. If a data center or part of the data center fails, we can bring up that part of the data center in another location. So the application developers don't have to worry about the underlying infrastructure. The underlying infrastructure is built for resiliency, and magic just happens if a data center fails. You have to understand if you're going to approach this in multi-cloud via the application or the infrastructure layer. From a SaaS versus IaaS versus PaaS layer, SaaS solutions, there's really not a DR use case. If Office 365 goes down, other than having your local offline copies available to you, there's really not a whole lot you can do to fail over a SaaS solution to a different platform. IaaS and PaaS are different. Again, you can go at the application level for each one. Then RTO, RPO. You need to think about this a lot. In the private data center, we have a lot of control. I can run out to Best Buy and hack together a high-end PC and use my array-based snapshots or backups and restore a simple service to that machine. And that can be my RTO, RPO plan, and my plan is based on that. In the public cloud, that it's not that simple, or at least it's not very cheap for it to become that simple. You have to worry about cost, in my opinion, much more so when it comes around data and backup than you do on the when you're talking about hybrid cloud or private cloud instances of data protection. So I'm going to move a little bit faster because we have about 7 minutes. If you guys have any questions, go ahead and put them in the Q&A session. We have a question on firewalls that I'll come back to the end with. So data gravity versus service gravity versus what I call service gravity, what I think other people are pushed against me and call service inertia. This is, again, a dedicated webinar on, we've had this, Dave McCory, and I've had this conversation with Dave McCory, has come up with this, I think, time-tested idea that we move compute closer to data. The speed of light restricts how much data we can move to given compute. So it's much easier to pick up a rack of CPUs and move that rack of CPUs close to our petabytes of data than it is to move the petabytes of data to the compute. This image, I think, plays a pretty good role, is that services are starting to push back, I think, a little bit on that concept. I think gravity, again, I think data gravity is still very, very, very much a consideration when designing for multi-cloud. But as you start to leverage services like AI, machine learning, serverless, high performance compute, and when I say high performance compute, I mean thousands of CPUs and potentially GPUs, and in some case, massive storage, object storage. As that stuff exists in one cloud and you want to leverage a service or data in another cloud, you have serious problems. I mean, we can't in our own data center recreate what Google has done with TensorFlow and GCP. So when we're talking about creating algorithms based off a tremendous amount of data, how do we do that? That is a challenge. So we're going to talk about, you know, kind of the cool vendors in this space in general. From a security perspective, Zscaler, VMware, Cisco, Juniper, and when I say cloud native, I mean the native cloud solutions, which is what we basically have to do today. You need to look to some of these vendors to have these challenging conversations. I would say in any one of these vendors, go and give them the use case that I gave you and say, how do I protect against that? If they don't have a vision of how their products protect against it, I don't think they'll have a complete solution. But if they don't have a vision, I'd raise an eyebrow and think, man, you know what? Are these guys really getting multi-cloud? For backup and recovery, Druva, Dell EMC, NetApp, Cohesity, Rubrik, and the list literally goes on and on. I should have put a star next to Druva. I have done work for them in the past. They are fighting against the data gravity challenge by offering replication for data. So I can put my data near the cloud, let's say in a colo, and then I can replicate the bits and pieces that I need into a cloud. Or I can use these services as wholesale methodologies. I can use these technologies as wholesale methodologies to move workloads from the private data center into the cloud. For DR, Azure has a really cool service that they bought a company. You should talk to them if you're primarily in Azure. They have a really cool DR automation product if you're just talking about going from the data center into the public cloud. Zerto offers solutions for various public cloud, and NetV Pro is a service provider that I partner with and affiliate with to refer folks to implement some of these solutions. Which brings me to one of the questions: why is there a star next to some of the names? Again, repeatedly, if there's a star next to the name, I have some type of business relationship with those vendors, whether I've created content, advised them on their marketing strategy, or outright have a affiliation agreement with them. All right, last slide. And we're out of time out of the overall thing, but I'll go ahead. For those who can stay on, we'll go ahead and have the conversation around orchestration and workload management, which is important. Briefly, Netflix is the poster child for adopting a hybrid cloud methodology for legacy applications. A lot of people, when they think of Netflix, they think of the streaming service, which is leveraging AWS CDNs, and you have this perception that they're all in cloud. Netflix, just as recently as 2 years ago, published a paper saying we're finally all in cloud. Their journey was extremely interesting as it relates to the enterprise. They had a ton of legacy applications based on Java. They adopted Mesosphere, which is a data center scheduling platform, and built a container orchestration platform called Titus, which is akin to Kubernetes. So if you want to compare it to something that's available out in the open market, we have Kubernetes. They took their monolithic applications, their traditional Java apps, put them inside of containers, and then used Mesosphere to schedule workloads to be injected into their Titus platform and placed upon different cloud providers, whether it's, and in this case it's hybrid, if it's their on-prem private data center or it's AWS. Amazing story. I highly recommend you Google Netflix's journey to cloud and read about their Titus journey and their container journey, how they approached it from a organizational culture perspective and capability perspective. But in general, we get the same idea. We need a solution or a set of solutions to take code, whether that's legacy code, it's a straight up SAP application workload, or if it's a cloud native platform, and use Kubernetes to schedule that platform or that workload across clouds. I am not a fan of trying to adopt this anytime soon. Unless your job is to build applications and provide those applications to consumers, I say let the industry continue to work out these kinks. Trying to balance workloads across clouds is fraught with challenges. And if you go back, rewind the sessions, you know, you kind of get the idea of what some of these challenges are. Most of us don't have 90%, 100% of our workloads inside of containers, which kind of simplifies the challenges to an extent. Most of us still have these legacy workloads that require a lot of care and feeding, that are stateful workloads. Google will be one of the first folks. Kelsey Hightower preaches this all the time. Don't put stateful workloads inside of Kubernetes. It's not an easy thing to do. So, but from a high point, I wanted to make sure I talk about workload placement from a automated perspective. This is the nirvana of multi-cloud. While most people talk about this, I haven't ran into many traditional enterprises that's actively doing this, at least not doing this at scale. And if they've tried it, they've run into every problem you think you would imagine that you run into. I can't emphasize enough, don't do it. If you don't agree with me, come have the conversation on Twitter or email me, Keith, at the CTOadvisor.com, and we can have the conversation. So thanks for holding on. I'll go back and answer the one question that I haven't answered in the Q&A. If you guys have more questions, please go ahead and open it. For those of you who are a glutton for pain, I'll open up the audio to ask questions if I can figure out how to do that. So one of the questions, with most of the traffic now being encrypted, the placement of firewalls is now critical. Okay. It needs to be more on the instances or closer to the data consumption or transfer points. Couldn't disagree with you more. Firewalls are useless. Firewalls are useful when you're talking about, I need to protect my internet circuit from port scans, et cetera, et cetera. When you're talking about traditional use cases for protecting the shell from external resources, firewalls make sense. Where firewalls can't help us as much is when you talk about east-west traffic. And I categorize east-west traffic as multi-cloud to multi-cloud traffic, or server-to-server traffic. When I'm in AWS and I build an application inside of AWS, AWS gives me all the tools I need to protect workloads from each other. If there's a bunch of web servers in a VPC, by default, one web server shouldn't be able to talk to another web server just because they're in the same container. AWS gives me that capability. Inside the data center, VMware NSX gives me that type of capability. If I'm inside the enterprise and I have a workstation side by side, those workstations by default shouldn't be able to connect because the application patterns don't represent that type of traffic. So why are we allowing that traffic? We've interjected the concepts of firewalls to help with that, but in the public cloud, we need to put the policy as close to what you're calling the endpoint as possible because the data is encrypted. I can't inspect the data at the firewall. Breaking the encryption and TLS at the firewall is a fraud activity. As a developer, I'll just re-encrypt it again so that you can't break it. If you don't have the keys, you can't break the payload that I'm sending. You have to have a methodology to put the policy as close to where the data is either being generated or transmitted. So I have to be able to apply my policy at Lambda versus this. So have I looked into new concepts such as CASB? I didn't put ForcePoint on as a cool vendor in kind of this space. I should have. ForcePoint has bought a bunch of CASB solutions. So these are third-party cloud security products, and they've also bought traditional firewalls. So in theory, with their identity management solution, in theory, they have all of the tools needed to say that, hey, Keith Townsend is creating a Lambda function or has created a Lambda function that acts against an Oracle database that, wait, he doesn't have access to. I should be able to create a centralized policy that says the identity of Keith Townsend across all of my multi-clouds does not have the ability. There's zero trust between Keith Townsend and an Oracle DB that holds all of our sales data. So Keith Townsend can't exploit that security weakness to pull out all of the sales data out of the Oracle piece just because he could create Lambda code. So that's the nirvana of cloud security. We're not there. Multi-cloud security and a firewall today doesn't solve that problem, which I champion is a real problem in the enterprise people disagree with.